Over the years, the popularity of four-wheel drive and all-wheel drive has increased across the GM lineup. To meet the needs of our customers, GM has developed a wide variety of both four-wheel and all-wheel drive systems. Knowing which system you're working on is vital to ensure your service success. Hello, and welcome to this GM Service Know-How video presentation. I'm Michael Lloyd. This video presentation, along with the accompanying reference booklet, will identify the different four-wheel drive and all-wheel drive systems available from General Motors and their applications. Additionally, we'll describe an operational overview of each system, review some noise diagnostic basics, as well as some mechanical issues. Finally, we'll look at some electrical and electronic service concerns. Sometimes accurate diagnosis means finding that the vehicle is functioning as designed. When that's the case, remember, you cannot fix something that isn't broken. For example, if you had a customer that was concerned about unusual noises coming from the driveline, one of the first things you would want to look for is to see whether it's an auto four-wheel drive system. If it was, you would want to check to see if it was in the auto position. Driving on dry pavement in an auto four-wheel drive position can lead to additional driveline noise as well as reduced fuel economy. This needs to be communicated to the customer and the service advisor. If the service advisor is aware of this, he or she can communicate that information directly to the next customer that comes in with the same concern. To get better understanding of the complexity of the situation, let's begin by identifying the available transfer cases found on GM vehicles and their operational characteristics. Of the various GM systems available, they can all be categorized into two different types. The most popular is the four-wheel drive system. There are also all-wheel drive systems. Let's discuss all-wheel drive systems first. True single-speed all-wheel drive systems can be categorized as either on-demand or full-time operation. On-demand systems can be either electronically activated or mechanically activated. Full-time systems are designed for inclement weather and highway use. They divide torque between the front and rear wheels through either a viscous coupling or an open differential design. Four-wheel drive systems are two-speed transfer cases that come in the traditional part-time system, as well as full-time four-wheel drive and active types. Active transfer cases combine some of the characteristics of all-wheel drive and four-wheel drive. Part-time systems may be electronic or mechanical in shift design. Full-time four-wheel drive systems typically operate in 4-high and use an open differential to compensate for differing axle speeds. These systems also allow for traction control. Active systems can operate like the part-time design when they are operated in the traditional 2-high position. However, when they are used in the auto position, the systems transfer automatically to four-wheel drive when wheel slip is detected, much like on-demand all-wheel drive. Active transfer cases may use a preloaded or non-preloaded clutch pack in the transfer case. Let's start our review with the all-wheel drive systems, beginning with the new Venture Gear 136.
This single-mode active transfer case can be identified by RPO NP4. The transfer case shift control module monitors rear wheel slip based on inputs from both the front and rear prop shaft speed sensors. When rear wheel slip is detected, the transfer case shift control module sends a pulse width modulated signal to the encoder motor. This motor rotates the sector shaft. This applies a clutch pack which delivers a variable amount of torque normally delivered to the rear wheels to the front wheels. Torque is then ramped up until the front prop shaft speed sensor matches that of the rear prop shaft speed sensor. Torque is then ramped down until rear wheel slip is again detected. This system utilizes a preloaded transfer case. You'll find this system on 1999 through 2001 Bravada, as well as 1999 and up Astros and Safaris. The new Venture Gear 126 also can be identified by RPO NP4. It operates similarly to the 136 just discussed, but does not have a preloaded transfer case. Since the transfer case is not preloaded, no clutch shimming is required. The transfer case control module monitors the wear of the clutch and different clutch torque levels. The software learns adapt-ready positions for the correct clutch torques. The NVG 126 is used on the 2002 Bravada. The VersaTrack on-demand system is a one-speed all-wheel drive system. You'll find this on the 2002 and 2003 Montana, Venture, and Silhouette, as well as the 2001 through 2003 Aztec and Rendezvous. While this is a hydro-mechanical system, it uses electronics for system protection. This system is often referred to as the Steyr system. The propeller shaft assembly is mated to the output flange of the transfer case, which constantly rotates. It rotates at a rate equal to the average of the two front wheels. When front wheel speed exceeds rear wheel speed, gerotor pumps apply hydraulic pressure to clutch packs to send torque to the rear. The Pontiac Vibe uses a unique one-speed, on-demand, all-wheel drive transfer case. A viscous clutch at the rear axle provides torque to the rear axle when the front wheels lose traction. Full-time all-wheel drive transfer cases use either a viscous coupling or open differential. The new Venture Gear Model 149 is a viscous coupling design. It's designated by RPO NP3 and can be found on certain luxury utilities and pickups. This full-time all-wheel drive transfer case uses a planetary differential gear set that splits the torque between the front and rear wheels. Under normal circumstances, this torque split is 38% to the front wheels and 62% to the rear wheels. A viscous coupling is used to split torque front to rear, and when necessary, it works in conjunction with the differential to send more torque to the front or rear wheels during wheel slip. The viscous coupling also allows for speed differentials between the front and rear wheels during turns. The viscous coupling is not serviceable. If it's damaged, it must be replaced. To prevent damage to the viscous coupling, do not tow with wheels down, drive without one prop shaft, or drive with a compact spare tire for an extended period of time. The Borg-Warner Model 4473 is also a full-time all-wheel drive transfer case. It is denoted by RPO NP3. You'll find this optional transfer case on 2003 Express and Savannah. It operates very similarly to the NVG 149, as it also uses a viscous coupling to compensate for speed differences between the front and rear axles. The final full-time all-wheel drive transfer case in the GM lineup is also from Borg-Warner. It's the Model 4481. This transfer case, however, uses an open differential as opposed to a viscous coupling. An open differential works with traction control and vehicle stability systems. You'll find this transfer case on the 2003 Denali and Escalade.
That does it for all-wheel drive. Now let's review the four-wheel drive systems available. We'll begin with the part-time systems, starting with the new Venture Gear Model 233. This two-speed, part-time four-wheel drive transfer case features a shift control module with encoder and 3 push-button electronic shift control operation. It can be identified by RPO code NP1.
This transfer case provides 3 manual modes or gear positions. 2 high is the two-wheel drive high range for normal dry pavement driving. 4 high is the four-wheel drive high range. And 4 low is the four-wheel drive low range, designed for maximum torque. The transfer case encoder is mounted to the encoder motor assembly and is replaced only as an assembly. The encoder converts the selected shaft position into electrical signal inputs and sends these signals to the shift control module. You'll find this new Venture Gear 233 transfer case on 1992 through 2003 S10, Sonoma, Jimmy, and Blazer. 2 other part-time systems from new Venture Gear are the 261 and 263. These transfer cases use an electronic actuator to engage the front axle. The Model 261 uses a floor-mounted manual shift system, and the 263 uses a push-button system similar to the Model 233. You'll find the new Venture Gear 261-263 transfer case on Silverado and Sierra. The Tracker has a unique part-time four-wheel drive system. It uses a transfer case gear shift control lever for mode selection, but most uniquely it features a front axle actuator pump to provide compressed air for front axle engagement. The Powertrain Control Module, PCM, and the front drive axle actuator pump are the main components of the four-wheel drive engagement system. The actuator pump is PCM controlled. The pump provides compressed air to engage the front axle when requested by the PCM. BorgWarner also provides a couple of 2-speed, full-time four-wheel drive transfer cases, the models 4482 and 4484. They both use an open differential and traction control. Both cases have the RPO designation NR4. The 4482 features a push-button shift control switch for mode selection. Driver choices are 4 high, 4 low lock, and neutral. 4 low lock provides increased torque on loose surfaces such as sand. You'll find this transfer case used on full-sized SUVs like the Tahoe and Yukon, or the Suburban and Yukon XL. The Model 4484, featured exclusively on the H2, has a planetary-type differential with 2 different sets of pinion gears. This differential provides a full-time 40-60 torque split from front to rear. A push-button shift control switch for mode selection is located on the instrument panel. There are 3 modes: 4 high lock, and 4 low lock. Again, neutral is also available. A single press of the shift control switch begins transfer case mode change. The indicator lamp of the desired position will flash until all shifting criteria have been met and the selected mode or gear position has been reached. At that point, the indicator lamp will remain on constantly.
The last style of transfer case to discuss is the active four-wheel drive type. As mentioned earlier, these transfer cases combine characteristics of both all-wheel drive and four-wheel drive.
The new Venture Gear 226, 236, and 246 are 2-speed active or on-demand style transfer cases. They can be identified by RPO code NP8. On Trailblazer and Envoy, as of the time of this video's production, an RPO code is not used on this system. A push-button or rotary shift control switch for mode selection is located on the instrument panel. There are 5 modes: 2 high, auto 4-wheel drive, 4 high, 4 low, and neutral. During normal driving, the transfer case can operate in the auto 4-wheel drive mode. However, this reduces fuel economy and can increase driveline noise and wear. Also, the NVG 226 and 2003 model year 246 transfer cases require no clutch shimming. The transfer case control module works to minimize clutch wear and enhance different clutch torque levels. The software learns adapt-ready positions for the correct clutch torques.
Now that we have identified how the different systems operate, let's talk about what the customer hears and feels with these transfer cases. All-wheel drive vehicles offer the most transparent system operation. However, they do still exhibit some driving characteristics not found in two-wheel drive vehicles. An example would be torque steer. Full-time all-wheel drive systems are designed to be used in high and low traction situations. Torque is always going to all four wheels in full-time systems. Generally, they are quieter than similar four-wheel drive systems operated in 4-high and certainly in 4-low. These systems, however, will make more noise than conventional two-wheel drive systems. That's because there are more parts rotating and gear sets interfacing. Additionally, customers may hear more noise in turns, and sometimes they may actually feel the system operating even on high traction surfaces. On-demand all-wheel drive systems may produce some noise, or the driver may even feel the system engage. This is because these systems do not operate until wheel slip occurs. It's when the slip occurs that the customer may hear or feel the system operating. A big issue with part-time four-wheel drive systems is the sensation or feel, and sometimes the sound they create when engaged. With part-time systems, engagement and disengagement of the transfer case is most noticeable. As you physically engage and disengage the system with the push button or manual shift lever, the driver and passengers can actually feel the front axle connect, especially on higher GVW vehicles. A part-time four-wheel drive transfer case will make more noise while operated in 4-high and 4-low than in 2-high. Additionally, this noise may vary depending on transfer case type. GVW ratings, typically the higher GVW, the more noise, build variations, gear ratios, axles, tires, and most importantly, driving conditions. These style systems are designed to be used in four-wheel drive on loose traction surfaces such as snow, mud, or loose dirt. Since there is no device to compensate for the difference in speed between the front and rear axles, driveline binding will occur when these systems are used on hard pavement. We'll talk more about driveline binding in a bit. When used in 4-low, the extra gear reduction utilized will make even more noise when driving in 4-high. When the transfer case is in neutral and the engine is running, some noise is characteristic. When shifting the transfer case out of neutral with the engine running, some gear clash can be expected. These are typical operational characteristics of part-time four-wheel drive systems. Automatic or on-demand four-wheel drive systems are more transparent than part-time systems, but still produce some sound and feel feedback to the driver. During 4-high or 4-low operation, they will have characteristics of part-time four-wheel drive systems because there is no allowance for the difference in speed between the front and rear axles. In auto mode, a clutch pack allows for the difference in axle speeds and operates like an on-demand all-wheel drive system. Quite simply, some noises the customer may have concerns about aren't new, just more noticeable in today's quieter vehicles. They've always been there, we just never heard them before. The key to diagnosis is knowing what is an operational characteristic of the particular system and what is not. One of the first steps that can be used in determining if a noise is an operational characteristic is to compare the customer's vehicles to a similar vehicle. Similarities should include mileage, vehicle style, such as pickup truck or SUV, extended cab or short bed, and equipment. A comparison drive should help you determine if the customer's concern is valid or simply typical operation. Some noise will occur, particularly in part-time systems when vehicles are operated in four-wheel drive on high traction surfaces, such as clear, dry pavement. Now, this noise is the result of driveline loading and is natural. The noise also will usually increase the more the vehicle is turned. As the vehicle turns, the front and rear axles follow a different arc and turn at different speeds because there is nothing to allow for the different speeds between the front and rear axles. When the transfer case is locked, driveline binding occurs, and the only way to compensate is with the wheels to slip. This is referred to as crow hopping. Evidence of this condition can sometimes be found on the tire surface. One or more of the vehicle's tires may show small scratches around the circumference of the tire tread. These scratches are caused by the tire slipping or scuffing on the road surface. There are some basic checks that can be performed in the service bay and on the road. Additionally, there are some tire inspections that can help isolate the cause of driveline noise.
In the service bay, listen for noises as you check the gear range of the vehicle. Operate the transmission in all gear ranges, including park and reverse. Also, be sure to operate the vehicle in all gears with the four-wheel drive system engaged in both high and low ranges. Listen for gear grind. Take the vehicle on a test drive. Again, operate the vehicle in high and low range. Use the auto position if equipped as well. Drive it in a straight line as well as in turns. Also, drive the vehicle with and without acceleration load. Try to detect driveline noise. One last thing, try to recreate the same driving conditions as when the customer experiences hearing the sound. Sometimes bad road, washboard conditions for example, can cause customer dissatisfaction. While traveling down the road, a vehicle's tires will rotate a certain number of times in a mile. This is dependent on the tire circumference. If all of the tires are not exactly the same circumference, they will not turn at the same rate. This can cause driveline binding, resulting in noise. Therefore, check the tire circumference. Also, make sure the tires are the same size and brand. Different brands may have different circumferences, even though they are the same size. Also, make sure all tires are the same type. That is, don't mix off-road, all-season, or street tires. Look for uneven wear, too. Tires with different amounts of wear will roll at different rates. Proper and even tire inflation is important, too. A low tire will roll at a different rate. Therefore, tire pressure should be equal at all tires.
Other helpful tools for isolating noises are chassis ears and/or a vacuum hose. These can sometimes be more helpful than the electronic vibration analyzer, or EVA, because the EVA may catch too many frequencies, whereas the chassis ears, or rubber hose, may allow you to actually isolate the noise sources better. It's important to know what the baseline noise level of the vehicle is before performing the test. Also, be sure to listen for noise under acceleration and deceleration conditions. Okay, let's shift our focus now towards some mechanical issues with the various transfer cases we've discussed. Let's begin with the NVG 246. In some cases, the front axle carrier or pinion bearing fails. Now, this causes a higher turning torque in the front axle, which can damage the transfer case while operating in too high. The transfer case must be reconditioned or replaced. The new Venture gear models 261 and 263 sometimes will exhibit unusual transfer case whine or rumble. This is generally due to an internal component fault. It may even be a result of a previous repair where a damaged component might have been missed. Be sure to check the service history in these instances. It's also very important to do a careful cost analysis for for transfer case replacement versus repair. Repair requires inspection of all bearings and journals, along with replacement of any bad bearings and any components with bad bearing journals. Another condition described as a shudder affects NVG models 126 and 226. This usually happens during low-speed turns. On the 226, you'll see this only in auto mode. Sometimes the encoder will produce incorrect voltages because the encoder contacts are corroded. These incorrect voltages can be plotted on the Tech 2. Although this is a clutch shudder, do not flush the system. Flushing will not eliminate the condition. On the NVG 136, two possible causes of shudder are fluid-related. The active transfer case uses a blue fluid, part number 1237858. This fluid could be contaminated and should be changed before any other service is performed. Remember, the proper fluid is blue in color. Red fluid is not correct for this unit. If you find red fluid in the case, simply drain it and replace it with the proper blue fluid. Refer to transfer case fluid replacement in the service bulletin number 99-04-21-005A. Let's now turn our attention to the diagnosis of electrical and electronic issues. Although the transfer case has many mechanical components, all cases have various degrees of electrical and electronic inputs, outputs, and controls to ensure proper operation. We're going to review several, but first, let's look at a typical diagnostic procedure and follow it through. Always begin with a diagnostic system check for the transfer case you're servicing. During your diagnosis, realize you can't make a transfer case operate other than as designed. For example, shifting into 4 low, if all of the parameters are not met, the TCCM will not allow the selected mode to be engaged, and it will stay in the mode previously selected. Many times, proper transfer case operation requires information and inputs from other vehicle controllers and systems.
Although the diagnostic system check differs among the various models, typically they involve attempting to establish communications with the control module for the system. If the Tech 2 powers up, but you cannot establish communications with the module, the diagnostic system check has you verify power to the system controller. You may also need to verify the system grounds are good. Also, make sure the controller is properly programmed with the latest calibrations. The diagnostic system check may also call out specific DTCs and DTC groupings. Realize that transfer case DTCs are part of the C DTCs. C stands for chassis. P codes stand for powertrain. B stands for body electrical, and U codes relate to a fault on the vehicle's communications bus.
Realize that the NVG 233 does not interface with the Tech 2. So during diagnosis, you cannot use system input and output values. Make sure that you refer to the service information for diagnostic procedures.
Here's a review of DTC C0327, identifying a selector position fault. On this avalanche, you begin by checking at the encoder motor pigtail. For this application, the reference circuit should be at 8 volts. Here we have between 7 and 9 volts, which is good. If not in range, check for an open or short. Next, the encoder channel circuits are checked. Applications vary, so use the service information values. Here, they're all in range, around 5 volts. If the channel circuits are out of range, the diagnostic asks you to check the signal ground for an open or high resistance. If the open or short is not in the circuits to the transfer case shift control module, then the fault is with the module itself. If the signals are good, The selector shaft must be checked for a binding condition. Depending on your results, you may service the transfer case internally or replace the encoder motor. Regardless of the repair, be sure to clear codes. Then operate the vehicle to run the DTC and ensure it does not reset.
While you should always follow the service information for the exact model being serviced, here's an inventory of several diagnostic tips based on field experience and warranty analysis.
Some customers may comment that the service four-wheel drive indicator illuminates intermittently. After some investigation, you find that DTC B2725 is stored. The service information indicates the condition may be due to an intermittent fault in the transfer case shift control switch. The range mode switch circuit consists of 4 normally open switches. The shift control module supplies a regulated 8-volt DC signal to the switch through the 8-volt regulated circuit. The current travels through a 9.89 kiloohms resistor located inside the switch. It returns current to the shift control module through the switch signal circuit. In this diagnostic, you'll test for proper operation of the transfer case mode select switch by testing for proper voltage supply to the switch, proper resistance values in all switch states, a short to voltage in the switch signal circuit, and an open or short to ground in the switch signal circuit. Additionally, you'll look for a short to the 8-volt regulated circuit in the switch signal circuit and determine if the 8-volt regulated circuit is out of range. You will also test the 8-volt regulated circuit for a short to voltage, as well as an open or short to ground. If any of these values are out of the specified range, replace the transfer case shift control switch. Be sure to use the published service information. Also, do not replace the shift control module unless diagnosis specifically points to the module as the malfunction. After replacing the switch, be sure to clear any related DTCs since the transfer case control module, or TCCM, does not know that the switch has been replaced. Otherwise, the code will not clear until after 100 consecutive ignition cycles without the fault present. Another DTC, code C0308, will cause a customer concern of the four-wheel drive system inoperable, and the four-wheel drive service light will illuminate. The transfer case motor is a bidirectional permanent magnet DC motor. When energized through motor control A or motor control B, the ground is provided by the opposing motor control circuit and then grounded through the transfer case shift control module ground circuit. This DTC detects a short to ground in either control circuit. This can be caused by a seemingly unrelated electrical concern. With this DTC, a short to ground in the motor control A or B circuit causes the encoder and module to malfunction. Also, the ATC fuse may be blown. In this diagnostic, listen for motor noise when the encoder motor operates. Test for shorts to ground in the motor control A and B circuits, and test for higher than normal resistance in the motor control A and B circuits. You'll also test for a short to ground in the encoder motor windings, as well as test for continuity across the motor circuit. Finally, you'll test motor feed A and B circuits for a short to ground and for an open or high resistance. After performing a component check of the encoder motor to verify it is not damaged, check the TCCM and encoder motor ground integrity. Refer to the applicable schematics. If the TCCM and encoder motor grounds are good, check the main engine and body grounds. If any are loose, the TCCM and possibly the encoder motor are being used as an alternate ground path. This is something to look for when you're dealing with a repeat visit for service. Make any necessary ground repairs, replace the ATC fuse if necessary, and always clear the code with a scan tool. Another related condition to C0308 involves the encoder motor. If everything appears to be working correctly, check for current at the encoder motor. If there is current from the module to the motor, and you simply can't determine any other possible cause for the system not operating, replace the encoder motor. It most likely is the failed component. After replacing it, be sure to clear the code and test the system for operation. DTC C0550 will cause a customer concern of the four-wheel drive system inoperable, and the four-wheel drive service light may illuminate. This condition concerns Trailblazer and Envoy models equipped with the NVG 226. Inspect for aftermarket devices which could affect operation. Inspect for obvious damage to components, and perform the diagnostic system check. If the wiring and the fuse are okay, replace the transfer case shift control module. Be sure to reprogram the new module with the latest calibration. On the NVG 226, as well as the 2003 and later 246s, DTC C0379 involves the front axle actuator, which engages and disengages the front axle. When this code sets, all shifting for four-wheel drive and auto or adapt mode is disabled. The service four-wheel drive indicator will be on for the remainder of the current ignition cycle. The front axle actuator circuit consists of the front axle control circuit, which is connected to the transfer case shift control module, the front axle switch circuit, which is also connected to the transfer case shift control module, a battery feed circuit, and a ground circuit. Whenever a shift to auto four-wheel drive, 4-high, or 4-low is requested, the transfer case shift control module engages the front axle by grounding the front axle control circuit through a current limiting driver. DTC C0379 detects a short to ground, short to voltage, or an open circuit. This diagnostic tests the following: the front axle circuit for a current malfunction, the integrity of the front axle switch and battery feed circuits, the front axle control circuit for a short to ground, and the front axle switch circuit for short to voltage. Additionally, it tests the front axle battery feed circuit and the front axle switch circuit for an open or short to ground, as well as the front axle control circuit and the front axle ground circuit for an open or high resistance. Service history has revealed that sometimes the culprit of this condition can be wire routing under hood. As part of a visual inspection, look to see if the signal wire is shorting to ground on the AC clutch. If this is the case, reroute the signal wire away from the AC clutch and secure it with a tie strap. After performing your repair, be sure to clear any codes.
The importance of clearing troubled codes after completing the repair can't be stressed enough. The TCCM does not know when a component has been replaced and the vehicle repaired. For example, in the case of an NVG 233 with trouble code 2 and the encoder has failed, after replacing the encoder, you must manually clear the codes. If you do not, the TCCM will still think that the encoder has failed and the system will continue to not function. Four-wheel drive and all-wheel drive popularity has grown tremendously over the last few years. The challenge for you as a qualified service technician is to be able to quickly and accurately diagnose and service these vehicle systems correctly the first time. Be sure to read the accompanying reference booklet for additional information on four-wheel and all-wheel drive systems. Also, make sure you take the test online at www.gmcommontraining.com. Doing so will ensure that you are credited and that your participation in this GM Service Know-How release on four-wheel drive and all-wheel drive diagnosis is recorded. Competent and complete vehicle service will not only keep your customers happy with their vehicles, but it will keep them pleased with you and your dealership. Fixing it right the first time, every time, will give your customers years of worry-free motoring.